So proceeding further in metallocenes, we will study the synthesis of metallocenes and some routes which are employed for achieving this synthesis. First in this category is using a metal salt and cyclopentadienyl reagent. Sodium cyclopentadienide is the preferred reagent for these types of reactions. It is most easily obtained by the reaction of molten sodium and dicyclopentadiene. Traditionally, the starting point is the cracking of dicyclopentadienyl. Then the dimer of dicyclopentadiene is deprotonated by strong base or alkali metals. So as you can see in the reaction MCl2, that is the salt which is used, and then it is added to sodium cyclopentadienide, and following the reaction in the presence of the solvent, that is tetrahydrofuran, which is shown in the side diagram, or DME, which is also shown in the side diagram, is dimethoxyethane, and in their presence, M, which can be preferably vanadium, chromium, manganese, iron, or cobalt, can yield our metallocene. Sodium cyclopentadienide here acts as a reducing agent and also as a ligand in this reaction. Next, we shall proceed using a metal and cyclopentadiene. So this technique provides using metal atoms in the gas phase rather than the solid metal. The highly reactive atoms or molecules of metal are generated at the high temperature under vacuum and brought together with the chosen reactant on a cold surface. As you can see, M plus C5H6 gives MC5H5 and one atom of hydrogen. This is more favorable for reactions like lithium, where metal is lithium, sodium, or potassium. However, there is an alternate reaction also given for magnesium and iron. Let's move on to the third method, which implies using cyclopentadienyl reagent. Now, this type of reaction is available for variety of products. For example, thallium cyclopentadienide reacts with metal halide to give thallium chloride, which is poorly stable. In the same way, trialkyl tin, derivative of cyclopentadienyl, have also been used. Amongst many other methods developed, chromocene can be prepared from chromium hexacarbonyl, which is also shown in the reaction here, by direct reaction with cyclopentadiene in the presence of diethylamine. In this case, the formal deprotonation of the cyclopentadiene takes place. First of all, as you can see, it is C5H6, so deprotonation gives C5H5. This is followed by reduction of the resulting protons, and reduction of resulting protons gives hydrogen gas, which is liberated as H2. When the reduction of protons takes place to hydrogen gas, it facilitates the oxidation of central metal, and therefore we get chromocene as the desired product. Now, metallocenes generally have high thermal stability. Ferrocene can be sublimed in air at over 100 degrees centigrade, and no decomposition occurs. Metallocenes are generally purified in the laboratory by vacuum sublimation. But industrially, sublimation is not practical, so metallocenes are isolated by crystallization. Let's study the physical properties of metallocenes. Now, the bond between the metal and the carbon atom is highly covalent in nature. Most of the organometallic compounds exist in solid states, especially the compounds in which the hydrocarbon groups are aromatic or they have a ring structure. The compounds consist of highly electropositive metals such as sodium or lithium, which are very volatile and they can undergo spontaneous combustion. In many cases, organometallic compounds are found to be toxic to humans, especially when the compounds are volatile in nature. The compounds can act as good reducing agents, especially the compounds which are formed by highly electropositive metals. Amongst other properties which are on display, the stability order of metallocenes gives maximum values for iron, nickel, and moving towards the end are chromium. These compounds are paramagnetic in nature. They have very specific flame colors, and the IR infrared spectroscopy gives the bandwidth of the CH and CC bonds. As has been told that these compounds have very specific flame colors, so some of the popular compounds have been on display in this table, showing their specific colors, their melting points, and certain physical characteristic properties which make them different from others. So these physical properties are very unique for these metallocenes. So friends, that's all in this class. I hope you find this video helpful. If yes, then show me your support. See you in my next video. Till then, stay safe and stay healthy. My name is Mahima and thank you for watching. Bye bye.